Hi everybody, and thank you for joining this session. Today we will talk about Oracle fleet patching and provisioning, giving some deep dive details about the architecture of Oracle fleet patching and provisioning, and how to use it and what you can achieve. My name is Ludovico Caldara. I'm a product manager for fleet patching and provisioning, as I said, and also call it FPP, and I'm part of the Oracle database high availability, scalability, and maximum availability architecture product management team. So what do we do in our team? We take care about all the products that are database core technology products enabling high availability for business critical applications. And since here we are developing best practices and collecting customer insight and expert recommendation to provide our customer with the best practices and configurations to achieve the maximum availability that is possible. So we take all this recommendation, and doesn't matter if you are on a generic system or generic system or in the cloud, we do have recommendations for all those levels, and we generate what we call the reference architecture. So these are being quite common, quite well known among customers. We have the four reference architecture. The bronze one, where we have the best practices for single instance databases, where basically we have a basic protection that is given by different enterprise edition features, for example, flashback or backup and restore with Arman. And with Oracle Restart, we provide protection against failure by restarting automatically the database. Then we have the silver availability architecture that has everything that we have in bronze, but we also have Oracle Real Application Cluster that give protection from local failures, and also give zero application downtime for all the planned maintenance. So basically, by having the correct session draining set up, the application can keep working without noticing any maintenance for patching, for example. And application continuity also allowed to have protection for all the sessions that cannot drain properly. Then we have the gold architecture, where we put on top of the silver, we put active data guard replication that gives protection against site failures. So this is the highest level of protection that we can achieve without touching the application, without any modification to the application, just necessary to configure properly the client drivers, and then we can achieve this very high level of protection. And then the last and less common one is the platinum availability architecture, where we recommend using Golden Gate active-active replication and edition-based redefinition for achieving zero downtime application schema upgrades. So this is the platinum one is less common among customer. I mean, we have customer implementing it for very critical application, but it's the less common because you cannot achieve it out of the box just with Oracle technology. You also have to architect your application in a proper way so that it's tolerant for logical replication, because here we are introducing logical replication, and not all the application can tolerate logical failover properly. A couple of years ago, we've had a customer summit with our MAA reference customers, and we had a survey about their top pain points. And surprise, what happened is that most of our customers struggle with upgrades and patching of Oracle databases. And this is what this session will be about. Understand that it's not always easy to have a proper, easy patching when customers have many databases. And that's why we have developed this product, Oracle Fleet Patching and Provisioning, or FPP, that is a product and also a new way for patching databases and clusters. And the concept is that it is a central server, and from a central point, the customer can simply operate on a large fleet of databases, doing several kinds of patching and provisioning activities. And it works using the concept of out-of-place patching. What does it mean? It means that fleet patching and provisioning create a new copy of the Oracle homes for the databases, and the databases can be moved to the new Oracle homes instead of patching the binaries in place. So the difference is when you have in-place patching, you have to stop the instance, patch the binaries, and restart the instance. Do the same for all the servers. And at the end, run data patch to apply the patches also inside the database. Whereas with out-of-place patching, by installing a new version of the binaries that is already patched aside the old one, it's just necessary to restart the instance on the new home. This is much faster and enable for a recover mechanism in case, for example, something goes wrong with the patching, for example. FPP works on all the supported versions. So starting with 11.2, 12.1, 12.2, 18, 19, and soon also 21C. And it doesn't matter if it's single instance, if it's an Oracle restart, or real application cluster. And it works with, as I said, bare metal, virtual machines, engineered systems, for both CDB and non-CDB. Okay, so it is very generic purpose software that works also multi-platform, also on Linux, Solaris, and AX, not Windows. That allows, as I said, central management of big fleet of database in customer environments. There are different features. I would say the main one is to install, remove Oracle homes, check if there are any drift in the configuration of the Oracle homes among the different servers. But then also feature for the database, FPP can provision, patch, upgrade, or scale databases. We will see it in the next slides. There are operations for grid infrastructure. You can provision cluster, patch cluster, upgrade the grid infrastructure version, and also scale cluster by adding new nodes. And there are some nice integration features. For example, there is a nice REST API interface where customer can integrate FPP in their own environment, or FPP peering we will see later. It's a mechanism that allows to have different FPP servers, but exchange the images, the binary images among the servers, so that there is a homogeneous collection of gold images that customer can install. But I will also try to drill down and make a difference between what we consider the different levels of feature, because what we recommend to most of our customers is whenever you have to do operations like Oracle Home Management, gold image management, database patching, grid infrastructure patching, and drift detection, those are really the core feature that all the customers need, and where we concentrate the most, and we call them the core feature of fleet patching and provisioning. Then there are advanced features that not all the customers need to implement, but are there, like database provisioning or cluster provisioning, upgrades as well, and custom user action that the customer can use to plug in some specific script executions before or after the different operation with fleet patching and provisioning. And then we have the additional features that, to some extent, not all the customers use. They are there, they are available, of course. But I always suggest to start, when you start using fleet patching and provisioning, to start with the core feature and then integrate the new ones as soon as you become more confident with fleet patching and provisioning. So what's the architecture? FPP is based on grid infrastructure and is a component of Oracle grid infrastructure that you can enable when you have installed the grid infrastructure on the fleet patching and provisioning server or cluster. We can provision FPP server on a single node if you want to start simple, but we do recommend to install FPP server on a cluster so that you have the high availability that you have out of the box with grid infrastructure. So in order to install it, you have to install grid infrastructure and open all the required ports and configure grid infrastructure with the management repository. Because you might have noticed that with NetInC, we do not configure the management repository, the GMTDB, out of the box. It's something that you have to, it's a checkbox that you have to click on purpose during the installation process. Otherwise, it is a component that you can add in a second time, but it is a requirement, so you have to configure the management repository. And after you have that, well, there is this local RHP server that might be configured out of the box if you install everything with the management repository, but this is the local mode FPP that I will not explain today, but just to let you know that you can do some tasks with it, for example, database patching and grid infrastructure patching, but you have to take care in local mode about installing the images. So we don't need it if you want to have a centralized FPP architecture, so we can get rid of the local mode FPP server. And then we need to have the GNS that is used by the clients to resolve properly the FPP server IP address. And then we can configure and start the RHP server. And what do we have? We see that we have an RHP server process that is basically a Java container where we have our code running. We have a helper that is used on the server, on the clients, to execute some specific tasks. And then we have an ACFS that is used, that you can see we configure HP server with a storage, and we specify a disk group. This group is used to create an ACFS file system. And inside this ACFS file system, the FPP server will store all the gold images that it will use for later deployment to the FPP targets. Okay. So once we have configured it, we start it, and we are ready to start using RHP, FPP with a command line RHP-CTL. So this is an example as a first task. For example, you can start importing images and then start deploying them, but we will see all of this in detail. So we have to make a distinction between targets. I would say that all the targets that are managed, that are known by FPP server, are called FPP targets. Okay, they don't need to have any special software installed on them. When we don't have anything on them, FPP use SSH to connect to them. You can connect directly as root or use a pseudo user. Once we have this credential set, FPP can manage the target and copy the software using RackTrans. So RackTrans is a tool that has been developed internally by Oracle for moving a big amount of files, eventually also of a big size. And this is used, for example, when we do a cluster installation, we install everything on the first node, and then the copy on the second node is done by RackTrans, where we use the same mechanism to copy the images from the FPP server to the FPP target. And when we copy the images from the server to the target, then to the target we call them working copies, because they're copies of gold images that customer use for running databases. So working copies is the name that we use to identify the copy of the gold image on the targets. The FPP server is a listener that is used to track the progress of the copy. So at any time, it's possible for FPP server to know what's the progress of the installation part, for example. But let's say we have targets that don't need to have any special software on them, but we might also have targets that have grid infrastructure on top of it. So if we have grid infrastructure servers, we can configure an additional component that is called RHP Client. That component, we can have it only if we have grid infrastructure and only if grid infrastructure is at least 12.2. And this gives this target some additional capabilities like initiating its own operation from the client itself. So with this configuration, the operations can be initiated either from the FPP server or from the FPP client. And of course, there is a protection mechanism. There are grants and roles that make sure that nobody in a client can initiate operation for other clients. So a client can initiate operation only from himself. But the FPP server, of course, can initiate operation for all the clients. They communicate through TLS encrypted JMX or HTTPS, and file transfer is done always via RackTrans, even if we have an FPP client configured. So how do we add an FPP client if we already have grid infrastructure on our target, but we don't have configured the client yet? Basically, with RHPCTL add client, we specify which client we want to add, and the RHP server produces a manifest file that is encrypted that contains the credential that the FPP client will use to establish a secure connection and relation with the RHP server. So these credentials are encrypted and stored in secure key stores on the server and the client so that they can have a private communication. Then we can copy this manifest file to the client and use servctl add RHP client. So we configure the RHP client on the target server, and we pass this manifest file, and also we can specify the disk group if you want to have ACFS home provisioning. We can also specify an ASM disk group where the RHP client will create the ACFS file system to host the working copies, but this is not mandatory. There are two ways to provision working copies, and we will see it in the next slides. So how do I import images in the RHP server? There are two ways. The first one is to import an image, and we can do it either from a zip file or from an existing Oracle home that is not managed by the FPP server yet. So for example, if we have an Oracle home that we like that has all the patches and one-off that we use everywhere in our fleet, then we can import these binaries inside FPP server that we convert it to a gold image that can be used. Otherwise, I can use zip files. So I can zip the homes myself and ship it to the FPP server and add it as a zip file. Or even better, now that we have since 19C, if you have noticed, the Oracle homes are not an installation image that you have to, that when you run run installer, you are not copying anymore the binaries to the server, but what you're doing now is to unzip the binaries in the Oracle home directly, and the run installer just do the configuration of the Oracle home and attach in the central inventory. So the very same zip file that you download if you have an 19C from the Oracle download webpage you can import it directly as a 19.3 gold image inside the FPP server. The other way to import images is with the command add image, and these can be used only if the FPP server already knows the working copy. So if the working copy has been provisioned by the FPP server, we can modify and patch this working copy directly on the client and then import it back to the FPP server using this RHP-CTL add image. By the way, we can also deploy working copies on the FPP server himself and patch and create new gold images from the FPP server itself. And this is somehow what we recommend, because when you centralize the creation and patching of images only on the FPP server, you have the full control of what is happening. Whereas if you are provisioning images everywhere, and then you are patching and importing back those working copies again, you are never sure if there's been any special patching or any special modification to the working copies. So it's better to have the control and do everything from the FPP server. But of course, this is just our recommendation. You are also free to have an external server to prepare your images if you wish. This is what we have on FPP server when we start importing images. Like for example, here I've imported an image DB19.9, and I can query the images and see the list of images. In this example, it's just one, but we can have many, actually tens of different images on the server. And you can see that for each image, I have an ACFS file system that FPP server uses to store the image. So we can see that we have DB19.9 here, and I've declared the FPP server to use the RHP storage mount point. And here we have images and DB19.9. So this is the file system that is used for this gold image. And I can also check that I have snapshots on top of that. So FPP server always creates a snapshot to be sure that it will preserve the status, the initial status of the image, so that in case there are any new images that are based on this image, it will do snapshots and applying only the incremental changes so that it stays space efficient. So when it comes to provision the software to the remote targets, the most common way to provision is using local storage type. And how does it work? Basically, we want to provision the binaries on the local file systems on the remote target. And the existence of this file system is not managed by FPP. Okay, so the customer has to create a file system, for example, U01, and make sure that there is enough space to host the working copies. And then what FPP does, it copies the gold image as a working copy on the target. And what we see is that later it configure these binaries inside the target and register them into the central inventory. So this is an example of command that we use, RHP-CTL add working copy minus image, the image that you want to provision. We specify storage type local. We specify the users that we want to have as owner of the Oracle home. The client where we want to provision, in this case we specify client because this target has grid infrastructure and the RHP client configured on it. And we specify a name for the working copy and the path. So the Oracle home will be installed in this path that we see here. And the working copy name will also be the name of the Oracle home inside the central inventory. So this is important to know, and another very important fact is that the working copy names must be unique inside the fleet. So it is very, very important that you have a very strong naming convention, and that you put in your naming convention something that, like, for example, the name of the target cluster or the name of the target server, because the FPP server will use the name of the working copy in the future to understand where the working copy is deployed and where it has to do the operation. For example, here, if I deploy this working copy on client DBC67, in the future, I will not need to specify the client anymore, but I can only say I want to move the database from working copy, this working copy to another working copy, and will know automatically on which server it has to go, because the metadata is stored inside FPP server. And by the way, the metadata is stored in the management repository. That's why we have to configure it. This is where FPP stores its metadata. The other way to deploy working copies is using the RHP managed storage type. So when we configure the RHP client, as we've seen before, we can specify an SM disk group that will be used by the RHP client to create the ACFS file system that will be used to store the working copies. So when we had a new working copy with this configuration, a new file system is created for the new working copy, and the FPP server will transfer the image with ROCtrans to this newly created ACFS file system, and it will create a read-write snapshot. So the white part that we see here is the gold image that is immutable, and the read-write snapshot that is created on top of it will be the final Oracle home that is writable and will be used to run the databases. So in this case is FPP that take care of creating the file system, that take care that there is enough space, so everything is managed by the ACFS. So it's very useful. Not all our customers like it because they prefer to have control over the file systems and having the binaries deployed locally. Personally, I don't have any preference, and customer can use whatever they prefer. Both work nicely. But the big difference in the naming is that when we deploy working copy, we cannot specify the path for the Oracle home anymore, because it will always go under the mount point that we specify when we configure the RHP client. And as you can see, because it's a snapshot, we have .acfs /snaps / the name of the working copy that we specify /software home. So this is also a reason why some customers don't like it, because it tends to be quite long and a cryptic Oracle home path for our customers. We have seen how we can add working copies for the database images, but we can do the same for grid infrastructure images. So the easiest way to do it is always add working copy. In this case, the copies can only be local. We cannot deploy grid infrastructure images on ACFS because it's the grid infrastructure software that runs ACFS, so it doesn't make sense to have it deployed on ACFS. It can be local only and is copied as a software copy. So if you already have an existing grid infrastructure installation, the copy of the patched version or the next version will be done as a software only image. And then at the second time, we will need to do the patching or the upgrade. This is because RHP server, the FPP server, detects there is already a grid infrastructure installed, and then it configures as software only. Of course, FPP check if the ownership is the same, and eventually correct the ownership of the binaries to match the binaries of the already configured grid infrastructure that we have there. But we might have new server that we want to deploy with grid infrastructure, for example, new clusters or new Oracle Restart deployments. In this case, the FPP server does not know the target as an FPP client yet, and what we have to do is first install the gold image and then provide the response file for FPP server and specify this response file in the command line so that FPP server can take care of installing and configuring the cluster. So in this way, there is a little preparation for having the proper response file prepared, but then we can have the response file deployed on our target and point it from the command line, specified as a parameter, and having FPP server that take care of the cluster installation for us. So this is very, very cool. Then let's talk about, we've talked about installation so far, let's talk about patching here. So the first thing that you would like to patch if you are in a rack environment is to patch the grid infrastructure, because as you might know, we always recommend to patch grid infrastructure and then to patch the database. If you stay within the same version, it's also possible to have a database at a higher patching level, but this is not what we recommend in general. So the first thing is patching the grid infrastructure. What we do is we have a command to move the GI home, so the grid infrastructure home, from one working copy to another one. So here, as I said, we specify the working copies, not anymore the client. And FPP server always acts rolling. So it will relocate the services and always do one node at a time. So we start by relocating all the services from node 1 to node 2, patch the node 1, relocate the service back to node 1, patch the second node, and then if you specify key placement, all the services go back where they were at the beginning of the operation. As I said, it's always rolling, and what is really also important to mention is that if customer has specified drain timeout for the services, this drain timeout is respected. Okay. So if I have, for example, 60 seconds for a service, RHP server will relocate honoring the service drain timeout. Okay, but we can also specify different drain timeouts from the RHP-CTL command line. And by default, as I said, it's always rolling. If we wish, we can also have it non-rolling by specifying minus non-rolling parameter. And by default, it's serial. That means that if we have 4 nodes in a cluster, it will do node 1, then node 2, then node 3, and then finally node 4. But we can also specify batches and say, I want you to do node 1 and 2, and then do node 3 and 4 in parallel. Okay? And we can also specify what we call the smart move that does FPP server. So we specify a level of availability that we want to guarantee. For example, we can say, I always want to have 50% of our node available in the cluster. And FPP will automatically divide the nodes in different groups and make sure that this percentage of availability is respected and patch accordingly. There is a new feature that we have announced some months ago, that is the zero downtime grid infrastructure patching, that allow to patch the grid infrastructure without stopping the instances. So when we do specify the move GI home with this minus TG IP, it will move the grid infrastructure but the database will stay up and running. So we have no brownouts. This is absolutely an incredible feature. But you have to be careful that all your databases need to be at least 19.8 because this is a feature that has been introduced in 19.5, and at the beginning it was there were a few issues that were preventing for working correctly in all the cases. So you need to have databases to this version. If you don't, if you have, for example, a lower version of databases, that it will not work. And also we do recommend to use it only for emergency patches. Because by doing this, by using the zero downtime grid infrastructure patching, we do not update the AFD drivers and ACFS drivers because they are in use by the databases. So you always need to have a deferred restart at some point. So we do not recommend to use zero downtime grid infrastructure patching for normal patching, but only in emergency cases where you have stability or bad performance problem and you need to apply one-off patch on grid infrastructure immediately. Then in that case, it's okay to do it and defer the full restart of the node, of course rolling, but when it's possible to do it, okay? So in general, we recommend to use the normal approach, that is stopping the instances and updating the drivers at the same time of the grid infrastructure patching. Another operation is upgrading the grid infrastructure. So it's the very same, doesn't change much. We use RHPCTL upgrade GI home. It's always rolling. It always honors the service drain timeout. And it acts the very same way, except that we are not doing a patching operation, but it is a more complex GI upgrade operation. But from the point of view of the customer, is always one command, and FPP take care of everything. Talking about databases, FPP can provision databases. We can provision single node, rack 1 node to FPP clients. And we have the RHPCTL add database for that. What it does internally, it uses database creation assistant. So by default, it uses the general purpose template. But if customer wish to have a specific template, they can specify it with a parameter -db template. And the template itself might be stored either in the gold image itself or locally on the FPP client, okay? So if you want to have the template on the FPP server, you have to create the image with this template embedded inside it. If you don't have this template inside the image, then you have to create the template file on the client itself and specify the path to FPP server that will use it and run the DBCA with the core template file. And this is an example of creating a database with RHPCTL database. We specify the working copy where we want to deploy the new database. We specify the database name, the DB unique name, where to put the data files, the type of the database, we want CDB or non-CDB, and the template, okay? So in this case, it is a template that is included inside the gold image. And after deployment, we can see that we have in Oracle-based configuration tool DBCA, we have the subdirectory with the DB unique name of the database that we have created, and we have all the logs that we can use to double check the creation of the database for, I don't know, any special action, if it has been created the way we wanted. So once the database is there, we can patch it, of course. So we can patch also existing database. We don't need to have a database created by FPP. All the databases that we already have in our fleet can be patched with FPP. And for the patching, we use RHPCTL move database. So again, first we need to provision the new working copy, the patched one, in the version that we want to move the database to. And then again, FPP server will move the two instances. It will drain the service gracefully, move the instances, and when all the instances are moved to the new working copy, the patched working copy, it will run data patch automatically for us. Okay, so again, no customer action before or after patching. Everything is done by FPP. Yeah, as I said, rolling by default, automated data patch execution, and the drain timeout are respected by FPP if we have specified them for our services. For the database upgrade, is a little bit more complex, not because FPP does it differently from the other operation, but the upgrade operation itself is more complex. Okay, so it should be as easy as doing RHPCTL upgrade database, but we all know that upgrading the database is not that easy, especially for giving you some background that FPP in 19C, up to 19C, use the database upgrade assistant. And the customer needs to do some pre-checks, have some fix-ups, run the database with upgrade the database with RHPCTL, that we use the upgrade assistant to upgrade everything. And we all know that sometimes it might work properly, but sometimes it might give error. So FPP server is just the man in the middle that runs the BUA, but then if the BUA fails for some reason, for example, deprecated feature, for example, we have something in the database that cannot be upgraded that easily, then we need to have some more careful planning. We have had many customers asking for integrating the new auto upgrade tool in FPP, and give you a good news, this is already available in 21C. And when I say already available, it means that it will be available soon for you, but the FPP 21C, as I said, is already deployed in our Oracle Cloud infrastructure, and to some extent you can try to use it already there, but in the next months, hopefully weeks, you will have the 21C coming out, and you can install then FPP 21C and use auto upgrade for your database upgrades. I've explained it at the beginning, probably not. We can have image series for our gold images. What is about? We can organize our gold images in a series that is has a logical order for applying the images. For example, we can have a series for database 19C and have 19.3, then 19.4, 19.5, up to 19.10 we have now. This is interesting because the users on the target servers can subscribe and have notification that, hey, there is a new image version that is available. You can deploy it now if you want. So there is this notification method for users, and it also gives an ordered method so that we can always check if we are at the latest available image, or if any image, we can order them and see if you are respecting the correct order of the images. So we will not, for example, patch database from 19.9 to 19.8 is always the other way around. I know that might sound obvious, but you can have strange naming convention or many one-off patches, and you want to be sure that you are always using the latest one that contains all your favorite one-off patches, for example. We can have user actions. Those user actions can be defined before or after a specific operation type. For example, after an add database operation, and we can specify a shell script that is executed before or after that. Just to give you a common example that many of our customers implement, is a post database creation script where we add the database as an enterprise manager target, or for example register the new database in the Arman catalog. FPP Server called this script by passing a few variables as parameters. By using this small loop, you can convert the parameters to variables and use this variable in the action script. So all those variables are documented in the FPP documentation. You can use them and have your script doing what you expect to have after an operation with FPP. Another nice feature is drift reporting. In this example, I say I want to have a drift report for a specific image. And what FPP will do, besides giving the details of the gold image, will also say, look, you have some working copies that are based on this image that have additional one-off patches. So there has been a drift. Someone has modified the working copy. This might be expected or not. But this gives an idea first that there are some working copies that have been modified. And second, it gives you the additional information of which one-off patch has been included in the working copy, so that the next time that you prepare a gold image, you want to be sure that you include that one-off inside the new gold image, so that when you will patch all the databases to this new gold image, you will have no surprises, and all the one-off that you expect will be there in the new image. So it is quite useful. There is also an audit feature. So at any time you can query and see what have been the latest operation inside FPP server. You can filter per operation. For example, add working copy. I can see here the last operation that have been done of type add working copy. What was the time, who ran it, from which server, and what was the outcome. Then we have server peering. I said at the beginning of the presentation that we can have different servers sharing the same images. Why would we want to have different servers in our environment? Basically, if you have a central server and then you have many subnets, many data centers, many regions in your company, then having a central server first is a problem for opening all the ports that the FPP server requires. We do recommend to have the FPP server in the same subnet as the database server. And second, there is a lot of transit between the different subnets. So this might be slow to deploy the servers, to deploy the images on distant targets. So what we recommend is to have an FPP server per data center, and then synchronize the server by exchanging the images once among the servers, and then doing local deployments from one FPP server to its target in the same data center. And in order to establish this peering between two servers, first again we produce a manifest file of the FPP server for the other FPP server, and then we import it by doing RHPCTL register server, and at this point they will be buddies, and then we start exchanging the new version of the images. REST APIs, not all the operation, but almost all the operation that we can run from the command line, we can also run from REST APIs. So customers can enable HTTPS, can create users that can be used for the REST APIs, and then can integrate these RESTful APIs from their favorite integration tools. We have customers that do it with Apex. We have customers that do it with Rundeck. We have customers that use Ansible either with the REST APIs or with the command line. So it's quite easy to integrate FPP Server in your favorite tool. So you don't need to do all the tasks, all the command lines manually, but you can actually integrate with a CI/CD pipeline, for example, if you wish. Just be careful that time I'm speaking now, the FPP documentation is inside the clusterware documentation. So it's a paragraph inside the clusterware documentation, but there will be a new book for FPP, specific to FPP. There will be a separate book. And this is coming, we expect it really now. I don't know, perhaps this time is being published right now. But the REST API documentation is inside the REST API for Oracle Database book. This is because this REST API for Oracle Database book is the book where we centralize all the REST APIs that we expose, all the different endpoints that we have for ORDS, for Apex, for fleet patching and provisioning, the new REST API for the clusterware, everything is there. So we didn't want to duplicate this information in the FPP book. You have everything there if you want to give it a look. Then the last feature that I will explain about FPP is the zero downtime upgrade. This is probably the most complex feature, and understand that there are not many customers willing to do upgrades like this. For me, it's incredibly powerful. It's incredibly automated how it works, but it can be kind of overwhelming understanding what happens behind FPP. So the zero downtime upgrade is a feature that allows to, as the name says, upgrade your database without having a full database downtime. It automates all the phases that we usually do manually to have what we call the rolling upgrades. So cloning the database, switching over to the clone, upgrade the original one, sync up the logical replication, and then switch back. So everything is automated. It is space efficient if your database is on ACFS because it uses ACFS snapshots. But if your database is not on ACFS, which is very common, then you need to have twice the space of the database in order to have this full clone. And FPP use only local clones, so we cannot use remote clones in order to achieve the zero downtime upgrade. FPP always sets up the clone locally, so this is another reason why we need to have also additional memory, additional space on the server, and why not all the customers are keen to use this feature. But it's there, it works, it's useful, and we can use it with two different technologies. We can specify that we want to do zero downtime upgrade using Golden Gate. In that case, it will do a clone, set up a Golden Gate replication, and do all the switches and so forth using Golden Gate. In the other case, it uses data guard or active data guard, because what it does, it uses the transient logical standby and DBMLS rolling package. So in this case, it will set up the physical standby first, then convert it to logical standby, do the upgrade, sync back, and then convert it back to a physical standby by flashing back to the previous incarnation, the former primary database. So it's quite complex, but it's possible to achieve all these using zero downtime upgrade. So it's really an end-to-end automation, but you need to have the licenses for either Golden Gate or Active Data Guard in order to use this feature. So that's all for me. There are a few links that you might be interested to. The first is the fleet patching and provisioning landing page. If you go there, you have all the other links mentioned. So remember oracle.com/go/FPP, and you can get all the other links. The documentation, as I said now, is a chapter in the clusterware documentation, but a specific book for FPP will come out soon. There is the technical brief white paper if you want to read something in the evening before going to bed. The cookbook is a nice PDF with all the command line example and output example that you can read. This is useful if you're testing FPP and you want to copy the command line with some full example and see if the output that you get is the output that you should also expect. And then there is also this nice project by the Rackpack team, is Ruggero Citton that did this. It is a project that allows you to provision fleet patching and provisioning server and a target by using Vagrant and VirtualBox or KVM. So if you want to jumpstart and have something to try immediately on your laptop, even if it might be a little bit demanding in resources, but if you also have virtual machines with KVM in your company and you want to use it, you can use this project and have it. By the way, I'm also planning to have Terraform scripts to deploy in the OCI. So if you have a tenancy and a compartment ready to host FPP server, very soon I will be publish, hopefully, the Terraform script that will enable you to have a full setup of FPP server and the target ready to use inside the cloud. Then we are open for questions.